And next up is the derivative of the inverse function of secant of x, and I think you're starting to get the tango of how to do derivatives of inverse trigonometric functions. So we take the secant of both sides, secant of y then is equivalent to x. Now we take the derivatives of both sides, and the derivative of secant is tangent multiplied by secant. So we'll have tangent of y multiplied by secant of y. That's the outside of the function, and the inside of the function is y. So dy over dx, since we're deriving with respect to x, and all of this is dy over dx is of course what we're solving for, and the derivative of x with respect to x is of course equal to 1. So here we have dy over dx is equal to 1 divided by tangent of y times secant of y, since that's what we divided on both sides, and since y is just the inverse of secant of x, of course this would just be equivalent to x times tangent of y. Well, how can we solve for tangent of y then? Well, I think this will be easier if I just draw a shape. Well, we know that secant of y is just secant of an angle, since y is the inverse of secant of x, and all inverses of trigonometric functions, of course, always corresponds to some angle. And secant is the same thing as 1 divided by cosine of y. But what is cosine of y? Cosine of y usually means the adjacent side divided by the hypotenuse. Well, 1 divided by the adjacent over the hypotenuse is of course the same as the hypotenuse over the adjacent side. That's just how division works. Now let's draw a shape, and let's call this the hypotenuse and this the adjacent side. And we know that h divided by a was equal to x. Well, one way to solve this would be to say that the hypotenuse is x and the adjacent side is 1, because of course then the hypotenuse of the adjacent would be equivalent to x divided by 1, which of course is just equal to x, which is what secant of y was. And what is tangent of y? This angle is y then, of course. Well, the tangent is the same thing as the opposite divided by the adjacent. But what is the adjacent? What is the opposite side? This is the height of the triangle, and we know that from the Pythagorean theorem that 1 squared plus o squared is supposed to be equal to x squared. And o squared is equal to x squared minus 1 squared, which is just equal to 1. X squared minus 1 squared, and 1 squared is equal to 1. We take the square root of both sides, and we'll see that O is the square root of x squared minus 1. And then, since the tangent of y is just equal to 1, it's just equal to the opposite side, which is x squared minus 1, divided by the adjacent side, which is just 1. So of course this is just equal to the square root of x squared minus 1. So all of this is equal to 1 divided by x times tangent of y, and tangent of y was x squared minus 1. But when you plug this into a calculator, you may be wondering, why does it put an absolute value around x? Why is that? Well, remember that secant of y, or secant is the same thing as 1 over cosine, and the inverse of secant is of course just equivalent to some angle. So let's draw the unit circle, and the inverse of cosine, or the inverse of secant, is defined between the minimum and maximum angle for cosine, and that's just the upper half of the unit circle. Say this is 0 and this is pi. And at one point in our equation, we had tangent of y multiplied by secant of y. So this is the same thing as sine down here. And that's the same thing as sine of y divided by cosine of y multiplied by 1 over cosine of y. So if the angle is somewhere in the left of the unit circle, say somewhere around here, or let me draw it in red to make it more clear, somewhere around here, then cosine of y would be negative, since y is just this, which is equivalent to some angle. But then we'd have a negative value multiplied by another negative value, which is a positive value. And for every y, which for every angle which is defined within the inverse of secant of x, sine of y can never be negative, because it's only defined in the upper half of the unit circle. So this is always positive, and even if cosine is negative, it gets multiplied by another negative of itself, hence all of this will always be greater than 0. So since this is always greater than 0, and we have all of this can never be less than 0, can never be negative. And one way to prevent that from happening is by putting an absolute value around the x. And we don't have to worry about that, since we both have to worry about this thing, since a square root of something should always be taken as the positive.